Lighting control systems in residential settings offer a wide range of benefits, from energy savings to enhanced ambience and security. These systems allow homeowners to manage lighting levels throughout their homes, creating customized scenes for different activities and times of day. Traditional lighting control involves manually operating switches and dimmers to adjust the brightness of individual lights or groups of lights. While simple and cost-effective, this approach lacks the flexibility and convenience of modern automated systems. Automated lighting control systems use electronic devices, such as dimmers, switches, and sensors to control lighting based on pre-programmed schedules, occupancy, or ambient light levels. These systems can be controlled through wall-mounted keypads, touchscreens, or mobile apps, providing homeowners with centralized control over their entire lighting scheme. One of the primary benefits of residential lighting control systems is energy saving. By dimming lights when full brightness is not needed, homeowners can reduce energy consumption and lower their electricity bills. Occupancy sensors can automatically turn off lights in unoccupied rooms, preventing energy waste. Daylight harvesting systems use sensors to detect the amount of natural light entering a room and adjust artificial lighting accordingly, further reducing energy consumption. Another key benefit of lighting control systems is enhanced ambience. By creating customized lighting scenes, homeowners can set the mood for different activities such as watching a movie, entertaining guests, or relaxing after a long day. For example, a movie night scene might dim the overhead light and turn on accent lights to create a cozy atmosphere. A dinner party scene might brighten the dining room lights and dim the surrounding lights to create a festive atmosphere. Lighting control systems can also improve home security. Timed lighting schedules can simulate occupancy when homeowners are away on vacation, deterring potential intruders. Motion sensors can activate outdoor lights when someone approaches the property, alerting homeowners to potential threats. Integrated security systems can even use lighting to signal alarms or emergencies. Residential lighting control systems can be integrated with other smart home devices such as thermostats, security systems, and entertainment systems to create a seamless and automated living environment. For example, a good night scene might turn off all the lights, lock the doors, and set the thermostat to a comfortable sleeping temperature. Integrating lighting control with voice assistants, such as Amazon Alexa or Google Assistant, allows homeowners to control their lights with simple voice commands. When selecting a residential lighting control system, it's important to consider several factors, including the size of the home, the desired level of automation, and the budget. There are a variety of systems available, ranging from simple plug-and-play devices to sophisticated hardwired systems. Professional installation is recommended for complex systems to ensure proper wiring and configuration. It's also important to choose a system that is compatible with the existing lighting fixtures and wiring. Incandescent, fluorescent, and light-emitting diode, or LED, lighting each have different characteristics that may affect the performance of a lighting control system. For example, some older dimmers may not work properly with LED, which requires special dimming circuitry. Light-emitting diode, or LED, lighting has become increasingly popular in residential applications due to its energy efficiency, long lifespan, and versatility. Light-emitting diode, or LED, bulbs consume significantly less energy than incandescent bulbs and last much longer, reducing the need for frequent replacements. Light-emitting diode, or LED, lighting is also available in a wide range of colors and color temperatures, allowing homeowners to create customized lighting effects. When retrofitting an existing home with a lighting control system, it's important to consider the existing wiring and electrical infrastructure. Older homes may have outdated wiring that is not compatible with modern lighting control systems. In these cases, it may be necessary to upgrade the wiring to ensure proper operation and safety. It's also important to consider the load capacity of the electrical circuits. Lighting control systems can add to the electrical load, so it's important to make sure that the circuits are not overloaded. The National Electrical Code, or NEC, provides guidelines for calculating electrical loads and sizing wiring and overcurrent protection devices. The NEC Table 310.15, formerly NEC Table 310.16, provides ampacity ratings for conductors based on their size, insulation type, and installation conditions. It's important to consult the NEC and local electrical codes to ensure that all electrical work is performed safely and in compliance with regulations. In addition to energy savings, ambience, and security, lighting control systems can also improve accessibility for people with disabilities. Voice control and mobile app interfaces can make it easier for people with limited mobility to control their lights. Automated lighting schedules can also help people with visual impairments navigate their homes safely. As technology continues to evolve, residential lighting control systems are becoming more sophisticated and affordable. Wireless technologies such as Zigbee and Z-Wave are making it easier to install and configure lighting control systems without the need for extensive wiring. Cloud-based platforms are providing homeowners with remote access and control over their lighting systems from anywhere in the world. Artificial intelligence, or AI, is being integrated into lighting control systems to learn homeowner preferences and automatically adjust lighting levels based on their habits and routines. The future of residential lighting control is bright, with new innovations constantly emerging to enhance the comfort, convenience, and energy efficiency of our homes. One important aspect of lighting control systems is the selection of appropriate dimming technology. Different types of light sources, such as incandescent, fluorescent, and light-emitting diode, or LED, require different dimming methods. Incandescent lamps can be dimmed using simple resistance dimmers, while fluorescent and light-emitting diode, or LED, lamps require electronic dimmers that control the current flowing through the lamp. These cut dimmers are commonly used for incandescent and halogen lamps. These dimmers work by chopping off a portion of the alternating current, or AC, waveform, reducing the amount of power delivered to the lamp. Forward phase cut dimmers, also known as leading edge dimmers, chop off the beginning of the AC waveform, while reverse phase cut dimmers, also known as trailing edge dimmers, chop off the end of the AC waveform. Reverse phase cut dimmers are generally preferred for light-emitting diode, or LED, lamps, as they tend to produce less noise and flicker. Pulse width modulation, or PWM, dimming is another common method for dimming light-emitting diode, or LED, lamps. PWM dimming works by rapidly switching the light-emitting diode, or LED, on and off, with the ratio of on-time to off-time determining the brightness of the lamp. PWM dimming is very efficient and can provide smooth and flicker-free dimming. When selecting a dimmer, it's important to choose one that is compatible with the type of light source being used. Using the wrong type of dimmer can result in poor performance, flickering, and even damage to the lamp or dimmer. It's also important to consider the wattage rating of the dimmer. The dimmer should be rated to handle the total wattage of all the lamps being controlled. Overloading a dimmer can cause it to overheat and fail. In addition to dimmers, lighting control systems can also incorporate other types of control devices, such as switches, sensors, and timers. Switches are used to turn lights on and off, while sensors can detect occupancy, motion, or ambient light levels. Timers can be used to automatically turn lights on or off at specific times of day. Occupancy sensors are commonly used in bathrooms, closets, and hallways to automatically turn on the lights when someone enters the space and turn them off when the space is unoccupied. Daylight sensors can be used to automatically dim the lights when there is sufficient natural light available. Timers can be used to automatically turn on outdoor lights at dusk and turn them off at dawn. The design of a residential lighting control system should take into account the specific needs and preferences of the homeowner. Factors to consider include the size and layout of the home, the types of activities that take place in each room, and the desired level of automation. A well-designed lighting control system can enhance the beauty, functionality, and energy efficiency of a home. One important aspect of lighting design is the selection of appropriate lighting fixtures. Different types of fixtures produce different types of light, and the choice of fixtures can have a significant impact on the overall look and feel of a room. Recessed lighting is commonly used for general illumination, while track lighting can be used to highlight specific objects or areas. Pendant lights are often used over kitchen islands or dining tables, while sconces can be used to add ambient light to walls. Task lighting is used to provide focused light for specific activities such as reading, cooking, or working. Task lighting should be bright enough to illuminate the task area without causing glare or eye strain. Accent lighting is used to highlight architectural features, artwork, or other decorative elements. Accent lighting can add depth and dimension to a room and create visual interest. The color temperature of light is another important consideration. Color temperature is measured in Kelvin, and it refers to the warmth or coolness of the light. Warm light, with a color temperature of around 2700 to 3000 Kelvin, is typically used in bedrooms and living rooms to create a cozy and relaxing atmosphere. Cool light, with a color temperature of around 4000 to 5000 Kelvin, is typically used in kitchens and bathrooms to provide bright and functional illumination. Neutral light, with a color temperature of around 3500 Kelvin, is a good compromise between warm and cool light and can be used in a variety of settings. The Color Rendering Index, or CRI, is a measure of how accurately a light source renders the colors of objects. A high CRI indicates that the light source renders colors accurately, while a low CRI indicates that the light source distorts colors. For tasks that require accurate color perception, such as painting or photography, it's important to use a light source with a high CRI. In addition to the technical aspects of lighting control systems, it's also important to consider the aesthetic aspects. Lighting can have a significant impact on the mood and atmosphere of a room, and a well-designed lighting scheme can enhance the overall beauty and functionality of a home. By carefully considering the various factors involved in lighting design and control, homeowners can create a lighting environment that is both functional and aesthetically pleasing. It's also important to consider the environmental impact of lighting. Traditional incandescent bulbs are very efficient, converting only a small percentage of the electricity they consume into light. The rest of the electricity is wasted as heat. Light-emitting diode, or LED, bulbs are much more efficient, converting a much larger percentage of the electricity they consume into light. By switching to light-emitting diode, or LED lighting, homeowners can significantly reduce their energy consumption and their carbon footprint. In addition to being energy efficient, light-emitting diode, or LED, bulbs also last much longer than incandescent bulbs, reducing the need for frequent replacements. This can save homeowners money on both energy costs and bulb replacements. Light-emitting diode, or LED, lighting is also available in a wide range of colors and color temperatures, allowing homeowners to create customized lighting effects. Light-emitting diode, or LED, bulbs are also dimmable, allowing homeowners to control the brightness of their lights and create different lighting scenes. When choosing light-emitting diode, or LED bulbs, it's important to consider the lumen output of the bulb. Lumen is a measure of the total amount of light emitted by a light source. The higher the lumen output, the brighter the light. It's also important to consider the wattage of the bulb. Wattage is a measure of the amount of power consumed by a light source. The lower the wattage, the less energy the bulb consumes. When replacing incandescent bulbs with light-emitting diode, or LED bulbs, it's important to choose a light-emitting diode, or LED bulb that has a similar lumen output to the incandescent bulb. This will ensure that the light-emitting diode, or LED bulb, provides the same amount of light as the incandescent bulb. It's also important to check the compatibility of the light-emitting diode, or LED bulb, with the existing dimmer. Some older dimmers may not work properly with light-emitting diode, or LED bulbs. In these cases, it may be necessary to replace the dimmer with a dimmer that is compatible with light-emitting diode, or LED bulbs. By making the switch to light-emitting diode, or LED lighting, homeowners can save money on energy costs, reduce their carbon footprint, and create a more comfortable and aesthetically pleasing lighting environment. And remember to consult a qualified electrician for any electrical work to ensure safety and compliance with local codes.